Ever unwind a magnetic tape or adjusted the stylus of a phonograph or worked as a librarian? If yes, I hereby certify you as a file system manager. Congratulations! In computing, a file system controls how data is stored and retrieved. Without a file system, data placed in a storage device would be considered as a large body of data with no possibility to tell where it starts and ends. Let's walk through a visible file system around us. The book library. A library contains a collection of books, periodicals, and sometimes films and music tapes organized in a certain order, either by published date, the author name, the country, the genre, or by trending reports, arranged in racks. Racks contains names or numbers to identify. A catalog or the record is kept by the librarian to find what is located where. This improves the efficiency and reduces time to search the data. What if the record has been stolen without any trace? Oh my god, a total chaos. This is the method used in computing to organize files and directories in a hard disk drive, compact disk, flash drive, etc. to ease the process of retrieving. It helps the operating system to locate where the data is stored and how it may be accessed by a user or application. The operating system must understand the file system to open, display, and save the contents. If operating system doesn't support a file system, you may rely on a file system driver or think otherwise. Over the years, companies like Microsoft, Apple, Linux, Apache, Cisco are thriving to develop their own file system, which makes the file system robust, faster, secure, and resilient to corruption. All of us have confidential and personal data in our systems to deny others accessing it. Can we retrieve the data after an accidental deletion? Yes is the answer. When you delete a data, either a file or a directory, the system won't delete it from the storage. Instead, deletes the records to find the data, just like the stolen catalog in the library. The data persists in the storage until the partition has been overwritten by another data. Be careful when you handle a confidential data. Make sure it's shredded bit by bit completely using shredders. File system supports features such as volume management, file naming, metadata storage, permission management. There are various types of file systems used in computing based on the usage. Some of them are optical, tape, disk, and network file systems. ISO 9680 file system used in optical disks are cross-platform supported in various operating systems, but the data can be written only once. To overcome the limitation in volume size and data rewrite, UDF or Universal Data Format has been introduced. In practice, it has been widely used for DVDs and well suitable for recordable and rewritable optical media. Magnetic tape data storage has been used for years and still used by cloud providers to store data backup. As the data is stored in a sequential manner, magnetic tapes requires a linear motion to read or write data wound in long reels. In practice, cloud providers such as AWS and Azure provides virtual tape libraries typically used for backup and recovery purposes. Disk file system takes advantage of the ability of a storage media to randomly address data in short amount of time. Any storage media attaches with an operating system must be formatted to a specific file system. Otherwise, the computer will think the data is one large individual file. The common disk file systems are NTFS for Windows, ext4 used in Linux, APFS for Macintosh computers. Not all file systems are universal though. Some operating system file systems are proprietary. For example, if you format an external hard disk drive as NTFS, you can read or write data on a Windows PC. However, if you connect the hard disk to a Macintosh computer, you are limited to only reading the data. The situation is even worse in Windows, as it won't even recognize APFS or ext4 partitions. Everyone might be familiar at least with one file system, the FAT32, mostly used in flash drives. Flash drives are used to transport data across multiple operating systems, so it must be compatible. FAT32 is a compatible file system supported with a huge variety of devices, from smartphones, gaming consoles, cameras, etc. Try to store a file over 4 GB to a flash drive formatted with FAT32 file system and leave your results in the comment section below. Network file system is a client-server application that lets a user to manage files on a remote server, just like your Google Drive client on Windows. Network file system can be configured in two ways: centralized or distributed. In centralized file system, the data is stored on a central server, accessed by the clients using file sharing protocols such as NFS or SMP in Linux and Windows respectively. Network file system made an innovation in the modern data universe by clustering several storage servers in a network called Network Attached Storage or NAS. Distributed file system is a file system that is distributed on several file servers accessed over NFS protocols. The nodes are formatted with disk file system. It features redundancy, high availability, and performance, which are the key factors for data engineering. HDFS in Hadoop, Lustre file system in Linux, Ceph file system used in OpenStack are examples of distributed file system. However, irrespective of the type, file systems decide how data is stored and retrieved. Without a file system, the data stored on a disk is pointless. That's it for the episode. Thanks for watching.